We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system.
Are quite visible to the unaided eye at night. So no one person is credited with any of their discoveries. Cavemen saw these planets.
We close tonight with something that has left astronomers, physicists, and science enthusiasts across the globe absolutely stunned. The clearest and most puzzling look. Yet at Neptune, the most remote planet circling our sun, for centuries, Neptune has been cataloged, studied, and modeled as a giant icy sphere locked in a distant, predictable orbit. But now, the story is changing, and not just by a little. Observations suggest that Neptune is behaving in ways that flat out refuse to fit inside the laws we thought governed planetary motion. In other words, it may not be the Neptune we thought we knew at all. That astonishing possibility wasn't whispered in secret among scientists. It was announced boldly on stage by deGrasse Tyson himself, a man known for making complex science not only understandable, but unforgettable. Tyson isn't someone who tosses out wild claims casually, which is why, when he stood before a packed auditorium during a globally streamed symposium and revealed evidence suggesting Neptune is far stranger than textbooks have taught, the world stopped and listened. This wasn't just another astronomy update. It was a revelation that challenged centuries of assumptions. For generations, Neptune has carried the label of eighth planet from the Sun, a cold bluish world of gas and ice circling far beyond the cozy neighborhood of Earth and the inner planets. Discovered in 1846, Neptune was the first planet found through mathematics, not eyesight. Astronomers noticed Uranus drifting slightly off course in its orbit. Something massive was tugging on it. When they did the math, they found Neptune, invisible at first, yet real, revealed by gravity itself. Since then, we pieced together its story slowly. Through small telescope glimpses and one legendary visitor, NASA's Voyager 2, which flew past Neptune in 1989, Voyager delivered breathtaking images, a deep sapphire globe with swirling white storms, and the fastest winds recorded anywhere in the solar system. But that was only a brief encounter. We were left with snapshots, not answers. Neptune, despite being part of our cosmic family, has remained cloaked in mystery. And now, those mysteries are no longer hiding quietly. They're bursting into view. Recent data gathered by the James Webb Space Telescope, combined with cutting-edge Earth-based rays, reveal that Neptune's insides and magnetic behavior don't match any known model of a gas or ice giant. These instruments are painting a picture of a planet far more chaotic and volatile than we ever expected. Traditionally, scientists imagine Neptune as a neatly layered planet, a rocky core at the center, surrounded by a mantle of icy water and ammonia, wrapped in a thick envelope of hydrogen and helium gas, a tidy, logical structure. But the new evidence? It points to something else entirely. Instead of orderly layers, Neptune may be a restless mosaic of turbulent regions, zones where plasma-like materials churn unpredictably. Even more baffling are the warm patches detected beneath the cloud tops. At Neptune's distance, about 30 times farther from the Sun than Earth, solar energy is incredibly weak. By all logic, the planet should be frozen, quiet, and stable. And yet, it's radiating more heat than the Sun can possibly provide. Where is that extra energy coming from? Something hidden deep inside Neptune is generating it, and the surprises don't end there. Neptune's magnetic field, long known to be tilted and oddly offset from the planet's center, is now proving to be even stranger than imagined. New measurements show that it isn't simply skewed, it's unstable. Parts of the field seem to wander, drift, and even reform in cycles we've never seen in planetary dynamos. On Earth, our magnetic field is powered by molten iron circulating in the core. Jupiter's comes from metallic hydrogen compressed under crushing pressure, but Neptune, Tyson suggested it may be powered by something altogether different. Exotic ice is undergoing wild chemical transformations under extreme conditions, generating electric currents and magnetic chaos. Then came the speculation that silenced the room. What if Neptune isn't solid, or even fully continuous inside? What if it has vast cavities, pockets, or resonant chambers that trap and release electromagnetic and gravitational energy? A partially hollowed Neptune would be a radical break from everything planetary science assumes, but it would explain some of the bizarre signals we've been picking up. And if Neptune truly operates under such alien physics, then it forces us to rewrite the early history of our solar system. After all, Neptune didn't always live where it is now. Evidence suggests it formed closer to the sun before migrating outward. That migration shaped the Kuiper Belt, disrupted other planets' orbits, and may have even flung a fifth giant planet entirely out of the solar system. If Neptune itself is stranger than imagined, then our solar system's origin story might be far more chaotic than the smooth models drawn in textbooks, but Tyson's revelations went deeper. Among the most startling findings were unusual radio emissions emanating from within Neptune. Planets can produce radio waves when solar wind interacts with their magnetic fields, but the signals Neptune is sending don't fit that pattern. They come from deep inside, and their frequencies don't match any known natural atmospheric activity. Some researchers think they could be evidence of quantum-level processes unfolding in Neptune's dense, exotic matter. Others suggest entirely new forms of chemistry could be at play, and that leads us to one of the most mind-bending possibilities. Neptune may host superionic ice, a form of water that's neither solid nor liquid, but something in between. In this state, hydrogen atoms break free, leaving behind a slushy, electrically conductive soup. Laboratory experiments have hinted at this exotic phase of matter, but Neptune may be the first natural example we've ever detected. These bizarre ices could be the key to Neptune's heat, its unstable magnetism, and perhaps even its internal storms. Imagine oceans of electrified ice moving like conveyor belts under crushing pressure, driving turbulence unlike anything seen on Earth, Jupiter, or Saturn. Even Neptune's infamous winds, screaming at speeds over 1,300 miles per hour, may not be what we thought. Traditional models blame solar heating and atmospheric circulation, but at Neptune's distance, the sun is a faint glow. How could it stir such violent storms? Tyson suggested the winds might not be solar-driven at all. Instead, they may be powered from within, bursts of heat and pressure erupting from Neptune's core, forcing the atmosphere into chaos. If true, Neptune would be the first known planet whose weather is dominated not by its star, but by its own internal energy. And here's where the ripple effect really kicks in. Neptune is not alone. Across the galaxy, astronomers have discovered thousands of exoplanets roughly Neptune's size, so-called mini-Neptunes and sub-Neptunes. They're among the most common types of planets detected. If Neptune itself is far stranger than assumed, then all those distant cousins might be, too. Our classifications could be way off. The way we think about habitability, composition, and even the likelihood of life beyond Earth might need to be revised. Some of Tyson's comments even brushed against the boundary between planets and stars. While Neptune is far too small to ignite nuclear fusion, its unusual heat output and strange energy dynamics may put it in a category of objects we haven't fully defined. Not quite a planet, not quite a brown dwarf, something in between. A reminder that our neat categories are human inventions, and the universe doesn't always play by our rules. And when Tyson described Neptune as a chaotic system in equilibrium, he wasn't being poetic for its own sake. He was describing a planet that constantly balances itself through unpredictable forces, driven not by the quiet cooling of time, but by mysterious eruptions of hidden energy. A world of storms without end, powered by secrets buried deep inside. What makes all of this possible is the technology we've only just acquired. Without the James Webb Space Telescope and upgraded ground-based observatories, Neptune would still be hiding behind its distant shroud. Tyson stressed that point. The more advanced our instruments become, the more the universe reveals, and sometimes what it reveals forces us to rethink everything. Because if Neptune, a planet in our very own solar system, can surprise us this much, then what might await us in the thousands of other systems we're just beginning to explore? Neptune has gone from being the quiet, distant cousin of the gas giants to perhaps the most exotic member of our solar system family. And in the process, it's reminding us just how little we truly know about the universe we live in. So what do you think? Could Neptune's bizarre behavior force us to throw out everything we thought we knew about planets? Drop your thoughts in the comments. And if you're fascinated by these cosmic mysteries, make sure you like this video and subscribe. There are more discoveries coming that you won't want to miss. But Neptune's mystery isn't just about one planet behaving strangely, it's about what it represents. If a world in our own solar system, a place we've known about for less than 2 centuries, can challenge the very laws we thought were universal, what does that mean for the rest of the cosmos? Astronomy has always advanced through shocks like this. When Uranus's orbit didn't line up with predictions, Neptune was discovered. When Mercury's orbit betrayed Newton's laws, Einstein's theory of relativity rose to explain it. Now, Neptune's strange anomalies may be the next stepping stone toward a new understanding of physics. One of the most compelling mysteries is its heat. Neptune emits nearly twice as much energy as it receives from the sun. That shouldn't be possible. At its distance, solar light is too weak to sustain more than a frozen, sluggish atmosphere. Yet Neptune roars with storms, surges with winds, and glows with excess warmth. Some scientists speculate that radioactive decay deep in its core could account for part of this. But the scale is too large. Others think tidal heating from gravitational tugs might be a factor, yet Neptune's moons aren't massive enough to produce the effect. That leaves us with an unsettling possibility. Neptune's own matter may be undergoing exotic transformations that generate energy in ways we don't fully understand. Take superionic ice, for example. Laboratory tests show that under immense pressure, water molecules behave like no form of matter we've seen. Their hydrogen atoms detach and drift, while oxygen atoms lock into rigid patterns. The result is a substance that's part solid, part liquid, capable of conducting electricity like a metal. If oceans of this bizarre material swirl beneath Neptune's clouds, they could explain not only the planet's heat, but also its restless magnetism. Imagine rivers of electrified ice currents coursing through the mantle, fueling storms above and bending the magnetic field into strange, shifting shapes. And those magnetic shifts aren't subtle. Unlike Earth's relatively stable poles, Neptune's poles are chaotic. Observations suggest that its field flips, distorts, and warps on timescales far shorter than we expected. In fact, Neptune may be the most magnetically unstable planet we've ever studied. This instability hints at a dynamo powered not by molten metals or compressed hydrogen, but by a strange, alien chemistry that defies our categories. Then there's the question of cavities. The idea that Neptune might contain hollow or semi-hollow zones inside. At first, that sounds absurd. Planets formed by accreting matter under gravity, they should be compressed spheres. What if chemical reactions and phase transitions inside Neptune carve out stratified layers or resonant pockets? Then the planet might not be as solid as we assume. These internal chambers could trap energy, bounce electromagnetic waves, and release them in bursts, perhaps even accounting for the irregular radio emissions now puzzling scientists. Those radio signals are especially strange. Unlike Jupiter's strong but predictable radio waves, Neptune's emissions are sporadic and uneven, with frequencies that don't fit simple magnetic interactions. Some researchers wonder if they could be evidence of plasma storms raging deep inside, or even quantum processes flickering at scales we can barely comprehend. If true, Neptune could be the first planet known to produce quantum weather. Storms of particles and fields shaped by physics usually confined to laboratories. It all leads to a profound realization: Neptune may not just be a planet. It may be a laboratory of natural experiments, running tests in chemistry, physics, and magnetism under conditions we can't replicate on Earth. Every anomaly is a data point, a clue to processes that could reshape not only planetary science, but material science, energy research, and even quantum mechanics. And Neptune isn't just isolated in its weirdness. Across the galaxy, Neptune-sized planets dominate the catalogs of Kepler, TESS, and other exoplanet missions. Many Neptunes and sub-Neptunes are everywhere, orbiting distant stars by the thousands. If our Neptune is this complex, then those worlds might be even stranger. Some may be hotter, some colder, some orbiting tightly around their stars. What kinds of superionic oceans, exotic atmospheres, or unstable magnetospheres are waiting out there? It raises questions about life, too. Traditionally, scientists have looked for Earth-like planets in habitable zones. But what if habitability isn't so narrow? What if, in the extreme chemistry of Neptune-like worlds, new forms of organization, not life as we know it, but life as we don't, could emerge? Superionic oceans might seem hostile to us, but they could be the crucibles for alien processes we've never imagined. Tyson himself hinted at this possibility, that our assumptions about life are tied to Earth, and Neptune forces us to stretch beyond that bias. And then there's the possibility that Neptune blurs the line between planet and star. Its excess heat, its turbulent energy, its complex chemistry, these hint at a kind of protostellar behavior, as though it sits in a twilight zone between categories. It doesn't fuse hydrogen like a star, but it may be generating energy through pathways we don't yet understand. Could Neptune represent a missing rung on the cosmic ladder? Not planet, not star, but something else? If so, our system might host an entirely new class of object hiding in plain sight. The implications ripple outward. If our models of Neptune are wrong, then our models of solar system evolution must be revisited. Neptune's migration likely sculpted the Kuiper belt, scattering icy bodies and shaping Pluto's orbit. If Neptune is more chaotic than we thought, then its gravitational influence may have been far more disruptive. Some astronomers even wonder whether Neptune's instability hints at the existence of a lost planet, the mysterious planet 9 thought to lurk at the edge of the solar system. Perhaps Neptune's own strangeness is a clue to that hidden neighbor. All of this reminds us of something humbling. Science is not a set of fixed answers. It's a journey, constantly rewritten by new evidence. Neptune, once thought to be a distant, frozen sphere, now stands revealed as a roaring enigma, a world that refuses to fit the mold. It forces us to look forward. What comes next? Future missions to Neptune, long discussed but never launched, are now more urgent than ever. A dedicated orbiter, equipped with modern instruments, could peer beneath the clouds, map the magnetic field in detail, and confirm whether supersonic oceans or hollow chambers really exist. Voyager gave us a glimpse. Now, more than 30 years later, it's time for a return. Imagine the images we could capture: storms raging from within, lightning crackling across methane skies, auroras flickering in distorted magnetic arcs. Imagine instruments sending back proof that exotic matter phases exist naturally inside a planet. It would be one of the most groundbreaking moments in the history of science. And yet, even without that mission, Neptune is already teaching us. It's reminding us that the universe is not tidy. It doesn't conform neatly to human models. It thrives on exceptions, anomalies, and surprises. For every equation we write, there's a Neptune waiting to challenge it. For every rule of planetary science, there's an outlier that forces us to rewrite. That's not a flaw. That's the beauty of discovery. Tyson's revelation wasn't just about Neptune. It was about humility, about recognizing that even in our own backyard, we don't have all the answers. The cosmos is a teacher, and Neptune is one of its boldest lessons. Expect the unexpected. So the next time you picture Neptune, that distant blue world on the edge of the sun's light, don't think of it as a frozen afterthought. Think of it as a frontier, a laboratory, a mystery wrapped in clouds, hiding answers that could change not just how we see planets, but how we see the universe itself. And now it's your turn. What do you think Neptune really is? A chaotic ice giant, a protostar in disguise, or something entirely new? Drop your theories in the comments. And if this cosmic journey fascinated you, hit that like button and subscribe, because the universe isn't done surprising us, and we'll be here to uncover it together.